Okay, so here's the head scratcher problem I set you. If y is equal to 2 to the power of x, what is 4 to the power of x? So 4 to the power of x, well, if I want to write it as something to do with 2 to the power of x, let's rewrite 4 as 2 squared. And then we can write that like this. So we've got 4 to the power of x, which is the same as 2 squared to the power of x, which is the same as 2 to the 2x. Let's look at another way of writing that. This is also that. Multiply the x by the 2 and you get 2x. If y is equal to 2x, then 2x squared, that's y squared. So we've shown that 4 to the power of x is equal to y squared. So let's now look at the second part. That means I can rewrite that as y squared. Don't forget 2 to the power of x is y, so it's a quadratic equation. We can solve it in a number of ways. You could use the formula, you can use your fancy calculators. I'm going to factorize. But this equation is all to do with x, and I've got answers in terms of y. So let's remember up here, y is equal to 2 to the power of x. So that means 2 to the power of x is 8, and 2 to the power of x is minus 2. So looking at this first solution, 2 to the power of something is 8. That something has to be 3. 2 to the power of 3 is 8. So x is 3 is one solution. 2 to the power of something is minus 2. Well, it's very tempting to say minus 1, but no, don't forget 2 to the power of minus 1 is 1 over 2, so it's not that. And in fact, there's no value of x that would give you minus 2. 2 to the power of, well, there's nothing that you can do 2 to the power of to give you minus 2. So there's no solution here. It doesn't mean we've done it wrong. It just means that, as often happens with quadratics, this is a bit of a rabbit hole, and x is 3 is our only solution. Well done if you got somewhere with that. Okay, so that last example was an example of what I call a quadratic in disguise. The original equation looked nothing like a quadratic, but we did a little substitution and it turned into one. So this is a bit of a detour away from indices, but here are some other examples of quadratics in disguise. Excuse me. So let's have a look at the first one here. I can't help noticing that when it's lined up like this, where the powers of x are getting smaller, that this here is this squared. X to the power of 4 is x squared squared. So here's what I'm going to do. I'm going to make x squared equal to y, and that means that x to the power of 4 is y squared, and I'm going to rewrite this problem making that substitution. So x to the power of 4 becomes y squared minus 15x squared, so that's minus 15y minus 16. It's a quadratic. I can solve it. We've got a whole range of ways of doing it. I'm going to factorize this one, but nothing to stop you using a calculator or using the formula. So y is 16 and y is minus 1. But hang on a minute, let's go back to the original equation. The original equation was in terms of x, wasn't it? And we've got answers in terms of y. So what I now need to do is to go back to that substitution. So y is equal to x squared. So x squared is 16 and x squared is minus 1. So if x squared is 16, that means x is 4, plus or minus 4, don't forget. But there is no value of x, which when you square it gives you minus 1. So this is another situation where we get a solution that isn't valid. Okay, so you've got 4 others to try here, which are all along similar lines. With the last 3, you need to line them up like the first 2 are first before you do anything. But I'd be really interested to see how you get on, and in particular, I'd like to see your answers to, well, you can show me your answers to all of them, but these 2 here, I'd like to see your answers to. So can I get you to send me an email with a photo perhaps of those 2 solutions? And remember, I am at mcooper@ilfkimacademy.org.uk. I wish you all the best. I wish you a safe week, and you'll hear from me again on Friday.